start recording. Oh, no, no, no. Started the recording. I am here with you. I am here. I am here. I am here. Alright, let's go back to the consumer's utility. Last time we talked about a micro foundation for consumers' utility in a corner market and tried to match the parameters in this presentation to the ones we have from our Corno example here, which is only based on our presentation of actions and utility of the firms. Now I wanna jump into my assistance page and tell him this. Model and my second model is where is it? I cannot see it. Can you match the parameters? So what did we say yesterday was that in our core node demand is like this. SR is R, but it is negative. S is 1 and T is minus 1. And we have the micro foundation utility for the consumers as this alpha over 2 qi squared beta qi qj gamma qi, where an A is the matrix that is alpha on the diagonal and beta off the diagonal. And for that we need to be alpha less than beta less than minus alpha over n minus 1. One problem with our Corno previous or the first Corno example is that what about O1? Well, that's beta is R actually, that's true. And okay, alpha, what we have is it is minus 1/2 here, which is bad. Alpha is minus 1/2, not 1/2. And then consumer's net utility is the utility from Micro Foundation minus the price he pays for the items, which will be this. And then how do we come up with an inverse demand function? Because in Cournot, the firms are given the demand curve, the price inverse demand function. So if the price should be chosen by the consumers, AQ plus gamma 1n minus P equals 0, which equals P is AQ plus gamma n. Is it the inverse demand function? And then we want to see if the best response to this inverse demand matches our first example. Qi is the quantity of good I, W is baseline demand parameter, R is the parameter for substitution, theta I is the marginal cost of firm I. Second model representative consumer's utility function is this, which should be concave, and alpha is negative for sure. Beta Jn, exactly. The firm's profit maximization leads to the condition P minus theta minus alpha Q star. That's from the firm's point of view. Not really. Well, we computed that. Best response is I don't know. Beta should be negative for sure. And marginal cost. Theta I in both models represents the marginal cost of production for firm I. In both models represents the marginal cost of production. Yes, quantity interaction. No, alpha should be negative. It's obvious. Alpha positive leads to convexity. No. Alright, this card is right. What is my question exactly? Yeah, how to find inverse demand is AQ plus gamma 1n, is that it? And then we go to the, we have, that's the demand curve here given us. Jeez, I think we will change the whole setup. I don't want to sit on the table for this one. I'm done telling jokes. Tired. Went to the gym last night. I mean, Wednesday night I went kickboxing, but I'm telling you, lifting is another thing. I just learned it last night. You may go to kickboxing, but you don't feel that you are in your body. Like, after doing it, nothing beats a back day. That's what I'm saying. Alright, let me, because this cable will fall off. Alright. Anyways. Bank army. So if I go like, oh yeah, right. Alright. Let me see. I put you further, and if I go like this, that may hold the problem. It's really good. Just maybe this is better. Yeah. So yeah, sounds good. Okay. Jeez. Okay, that's better. So here's the deal. Yeah, I want to see the demand curve which is omega plus r derivative omega plus r derivative, and where is the other one? Is it the same solution once we maximize over v? Where is b? Okay, aq plus gamma n, which will lead to, is it on the diagonal a is, I'm not sure, on the diagonal a is alpha, which is minus 1/2, which gives us minus qi over 2, and off the diagonal a is beta, which is r, which gives us r sigma over qj, and it is also working. What the fuck? That's also working. Now look at the bruise. Look at this. Slowest bruise I ever had. Happened 2 days ago. Oh fuck. Alright, so gives us this demand curve. Perfect. And then qi star comes from this. These are all good. Okay, we are in agreement. I don't know why am I. Let me clear this stuff. So we know that alpha is minus 1/2, beta is r less than 0, omega is gamma, and that's it. S is 1 and t is minus 1. What happened? T is minus 1. Perfect. Jeez, these people are looking at us. So what else is left? Welfares. Let's look at the welfares. Where are they coming from? Wait, I stopped my whole Chrome. How did I do that? Alright. Alright. Firm welfare and consumer welfare. I want to know how we computed those. That's what I want to know. That's the shit that I like. That's the shit that I like. Yeah, that's what I like. So it's that this is the demand curve, and Cornell model, which is going to do that PMI where theta marginal cost of hence the welfare of the firms is this. So what was the welfare of the firm? Welfare of the firm is some of their utilities, right? Very easy. Some of the utilities, UIQ was minus 1/2 QI squared, QI PIQ minus theta IQ. UIQ was QI PIQ minus theta IQ, which is minus 1/2 QI squared plus R QI QJ plus RQ. Okay. Omega minus theta IQI. Omega minus theta IQI. Right? Welfare of the firms is sigma UIQ. But what is the best response to this demand curve? We also know that P minus theta should be minus alpha 3. We find that Q star. What is Q star? Okay, best response. Perfect. Firm's utility is PIQ minus. Exactly. That is what I have here. What are you talking about? And we want to maximize this. So, best response tells me that round UI, round QI equals 0. PI Q star minus theta I plus QI times pi I of Q. What is QI? Pi round pi I round QI will be minus 1/2. Minus 1/2 equals 0. Yeah, pi of Q is omega plus R sigma QJ minus QI over 2. So we need to have minus 1/2, and then it says alpha QI minus alpha Q. All right, 1/2 QI equals pi I Q star minus theta. It's true. Minus alpha QI star. This equation is right. I agree. Welfare of the firm is. This is also easy because what is the welfare of the firm? UIQ star is. Tell me, you guys tell me. Q star, QI star, PI of Q star minus theta I. But we know that PI of Q star minus theta I is minus alpha QI star, which ends up in UI of QI being minus alpha QI squared, QI star squared. And then the welfare will be exactly the sum of them minus alpha q star and q star inner product. Sounds good. X post utility, beta should be minus alpha minus 1/2. Yeah, that's weird. Whereas the X post utility of the consumer at the market clearing price is this. Utility of the consumer, X post utility of the consumers at market clearing price. Market clearing price, what is market clearing price? Pi of Qi star. But we know that Qi star also is in this Pi of Q star is AQ star plus get omega, AQ star plus omega. So minus alpha minus theta I. X post utility of the consumer at the market. Is it UQ or is it VQ? If it is UQ, what is the UQ? Well, UQ is the utility of consumers just consuming the product. But VQ is also minus the price they pay to the firms. And if we sum WF and WC, actually those PI star minus PIQI, this term PIQI here, that, and also the term in VQ cancel each other out, and the sum of the utility should be UQ minus theta QIs. Actually, what it means is that if all the firms were working for the consumers, they didn't charge them, the only cost was the cost of production is minus theta IQI, and the utility you generate by consuming them is UQ. Makes sense, right? Ah, fuck. But okay, it says WC is this term minus 1/2 Q star. I don't know where it brings it from. Can you let's ask ChatGPT and make it easier for us. Can you explain derivation of WC? Utility function is this. Here Qi is equal to alpha percent concavities. Qi beta captures the intersection between goods and landed linear shift, driving the inverse demand function. P is this, where A is this, then to the matrix J and module 1 to exactly pi alpha qi beta qj plus gamma. Carnot competition chooses its product, maximizes the firm's profit, depends on the price. So okay, if these firms are maximizing their profit, it doesn't mean that it maximizes net utility, right? Because they are maximizing this term, while net total welfare actually doesn't care about the price. Yeah. But cares about the quantity. The firm's profit depends on the price PI, which in turn depends on the quantities produced by all firms. Using the inverse demand function, the firm's first order condition. This is the true. We already fact checked this. Okay, consumer welfare. Is it exposed? That's it. Hence, optimal quantity quiet start demand. Consumers' welfare is the utility derived from consumers consuming the equilibrium quantities, perfect, minus the amount the consumer spend on these goods at the market price. So it is what we call V. The total welfare of the consumer can be written as this. From the utility function, it involves the quadratic terms in the quantities. From the utility function, plugging the quadratic utility function, evaluating at Q star, we get this. Inner product represented the utility. First term is this. Overproduction. Actually, it is giving it is valuing overproduction. Overproduction means my alpha is minus, so if you have more production, it will be bigger. I want to check this motherfucker. WC is UQ minus PQ star dot Q star. Or what is UQ formula? Is one half AQ star Q star, right? One half AQ star plus gamma 1n Q star minus PQ star. P of Q star, we have the formula for P. AQ star plus gamma n. Q star and AQ star plus gamma 1n. That's it. That's the inverse demand function that we have. Now if I show you, right, this formula here is UQ star minus P of Q star inner product Q star. UQ star is the first line formula, 1 half AQQ plus gamma Q 1n Q star, and PQ star is the demand curve, inverse demand curve, which is AQ star plus gamma 1n. Therefore, which is which gives us, I can take all Q stars on one side and have gamma 1n with gamma 1n goes away, and alpha Q star and 1 minus alpha Q star and 1 half Q star will be minus 1/2, and this goes away, so it will be minus 1/2 AQ star and Q star. I agree. Now I agree. Really, ChatGPT helps. And this term is also minus 1/2 alpha sigma qi star squared plus beta sigma I less than j. Actually, that will be 2 beta qi qj, which 2 and 2 goes away, will be minus alpha over 2 sigma qi star squared plus minus beta sigma qi qj I less than j. That's true, I agree. One thing I want to add here in the Corno model is finding alpha and beta. Then we have Bertrand model, we can compute similarly. I like to do it first, and then we go to the optimization. One thing is that my battery is dying. What should we do? I have no idea. Where is this? Now that we're in Corno, let's make it. Geez, should I go to the to the top? Yeah, guys, I think meanwhile a tablet can be charged. This is called efficiency. Parallel computing. Alright, parallel. While our tablet is being charged, I can update the notes here. Alright. Comparing. Where is it? Menu. Oh shit, you have nothing. Alright, comparing to share. However, we don't have an example here. Dude, I should type this. To this. We have alpha minus rank 1, 2, beta. This setup is terrible for typing. Beta equals r less than 0 greater than, what is it, minus alpha minus 1/2. Like that. And theta is theta and gamma is omega. I like to have less than 0, right? And that's it, that's good. All right, perfect. Let's go for the Bertrand, also add a label, Bertrand. Then we go here. So what is the story of Bertrand model? Bertrand is This is the model, and this is the example. So that's the example that we want to start with. %, still good. What is it telling us is that in Bertrand, the firms pick the price and the consumer decides how much of each product to use, the quantity. Charge from parent I, the demand curve of good I can be QI. For each product I, we have a demand curve. QI of PI or P? Yeah, QI of P. Where is it? Which decides how much the QI are. Equals omega plus R not equal I PJ, so minus PI over 2. So if quantity of product I, if the price of product I goes up, its quantity goes down. Good. If the price of other products go up, we expect the quantity of product I increases. Consumers say, okay, product I has less price, so let's buy more of my product I. Therefore, I expect R be positive. Is that true? R positive, exactly. Now, let's find RST, by the way. So R positive, and okay, I have to see the rest of the model. Where is the theta I coming up? Finally, with a marginal, okay, theta I is against marginal production cost. Marginal production cost. Therefore, UI of P, sorry, will be, well, you charge PI for quantity QI, I of P, minus theta I times PI. Again, this is the same formula. It should be QI of P times PI minus theta I. Which will give us omega plus R J naught I PJ PI over 2 PI minus theta I will lead to minus 1/2 PI squared plus R PI PJ plus pi omega minus theta I. It also has an extra term that doesn't show up in the utility. In the utility of the Corno, which is minus theta I times omega plus r. Well, actually it matters, doesn't pj, this extra term. So qpi minus theta I yielding the response finally with a marginal production cost. Then the best response is again, okay, the thing is that the term in the second line here, this term is independent, even though it includes pj, it includes pj, which is an action, but it's not action of firm I, so it is independent of pi, therefore does not affect best response pi star. Right? And it says if we want to compare, we need to just compare. And again, look at our setup. Our setup starts not with the UI, but it starts with the best response. Is this form r sigma aj s omega plus t theta I. If you wanna form a utility, we can add an extra term for other terms. Perfect. So then I can say r is r positive and s is 1 and okay, here we will have minus pi times theta I over 2. So t is minus 1/2. That's a smart. And it is, oh, it is plus, because we have pi minus theta I minus theta times time minus pi over 2 will be plus. So t is 1/2. S is 1, t is 1/2, I confirm, and that's it. I agree. Now, okay, go ahead. Oh, now we will go to the other example. The thing is that we defined utilities based on quantity. Well, actually it is true, it's just qi of p. Utility of the consumer is still the same formula. Utility doesn't depend, directly depends on the quantity amount you can consume, and then you have a net utility. So these formulas probably are stayed the same. In addition, each firm I chooses the price pi star that maximizes this, which ends up to the best response omega pi star. We have the formula. Pi star is always r sigma pj plus s omega. What is this? Just when you lie on the ground. S omega plus t theta I 1/2 theta I. The price pi star maximum. We write q where b is okay. So what is q? where P, note that by P is a matrix where diagonal coefficients equals to alpha prime and alpha diagonal coefficient beta prime alpha prime as a function of alpha according to proposition. We find that Q minus alpha prime. Okay, show us this more. It's alpha over n something, right? Oh, shoot. Then Jn minus 1 is Jn of this over this. Perfect. So Jn of A and B is A on diagonal, B off diagonal. Jn minus 1 of A and B is this. Alpha prime will be on diagonal of this, which is A plus n minus 2, alpha plus n minus 2 beta over alpha minus beta alpha plus n minus 1 beta, and beta prime is the off diagonal, which is minus beta over the same thing, alpha minus beta alpha plus n minus 1 beta. That's it. So using 3, what is 3? Okay. 3 is here. Yeah. P is AQ plus gamma n. That is for general case. And also I don't like this one because we have UQ, but here these are the consumers who decide. Oh, consumers decide on the price. So user decides the quantity. And this equation is with respect to the quantity. The derivation is with respect to quantity. Okay. Is that true? P is AQ plus gamma n. Is that true? consumers have a U of Q, consumer Q is defined there, then this tells us do the derivation with respect to Q, we get the price. How is that so? Oh, maximizes that. Alright. What does consumer do is consumer does maximize this. V of P and Q, I don't know, Q of P is U of Q of P minus the price it pays is P and Q of P inner product, right? But again, the problem of even in the Bertrand case, the problem of the consumer is deciding their Q. What is my QI? So we need to again do the comparison for QI, round V, round Q. And you can say Q and P are in a relationship with each other based on the best response, which is fucking QI of P omega plus R sigma J Pj minus Pi over 2. Nah, give me a second. Best response is not this. Best response is Pi star, the parameter is Rpj omega plus 1/2 theta I over. Because the price given is who decides, who chooses the price function? The firms in Bertrand, firms choose the price. And you have control over Q as the consumer. In Cournot, they choose, you give them a price function, they give you Q and you have to buy Q. Right? Okay, in Cournot, you give the price function, they decide to produce this amount of Q, and then you promise to buy the Q. In Bertrand, they give you a price and then you ask them, give me this amount of Q, and they promise to give you. So still you need to maximize on Q, which is round U, round Q, I, sigma. Yeah, that's actually round U, round Q, I minus Pi. So again, we will have the same equation, I agree. So equation 3 holds. Is it here? No. Equation 3 is here. It holds. P is gradient of UQ, which is AQ plus omega or gamma 1n, and Q will be A minus 1 P minus omega or gamma 1n, right? Which B is A minus 1, alpha beta prime this, we can find that. Then what is C? Oh, P, we have P. Oh, we have P. Where is P? PI, optimum PI. The best PI is R omega plus R sigma Pj plus omega plus 1 half theta I. So it equals A minus 1. P's. Fucking give me the formula. I'm hating myself, to be honest. This formula! So many formulas, so many fucking formulas. I hate them all. P, where is P? Alright, it's here. So I can say equals A minus 1, 0 and R, P, J N 0 and R, P, plus gamma 1N plus 1 half theta minus gamma 1N, which is A minus 1, Jn 0 and P 0 and R times P star plus 1 half theta. Q is minus alpha prime P star minus C. What is C? C is theta. P star minus C is R sigma Pj star omega minus 1 half theta I. Fuck me. I'm lost here. Q is B, P minus gamma 1N. Perfect. And we want to maximize over P, right? What is UI of P? UI of P is QI of PP minus. Or we can say this one. by the way, I didn't say what is alpha, what is beta. We didn't do that, that's why we are so confused. Let's do that. What is alpha, what is beta? Alpha was the A matrix. And once we have QB P minus thing, that's it. So many fucking formulas. Qi of P is omega plus Rj Pj minus Pi. This is the formula that gives Q equals B times P minus gamma 1n. So Qi will be alpha prime Pi minus gamma plus on J Pi star actually Pj star beta prime Pj star minus gamma. So on one hand, fuck you, it's just not enough space. We have these two formulas. We have these two formulas here. I hate this project because of so many big formulas. We have one this formula and the other one is this formula. These two are equal, so alpha prime should be minus 1/2 and beta prime should be R and minus alpha prime minus n minus 1 beta prime should be 1. Alright, alpha prime is minus 1/2, beta prime is R, and minus alpha prime minus n minus 1 beta prime, which is the coefficient for omega, should be 1. And now we are saying alright, where is this formula coming from? Minus alpha, like this formula, minus alpha prime, which is 1/2, minus n minus 1 R should be 1. So you're saying minus n minus 1 R should be 1/2. and r should be minus 1 over 2n minus 1. That is not acceptable. That is not acceptable. R can be anything positive. Alright, let's go over ChatGPT. I think I'm lost. I need bigger pages. This tablet doesn't work. I need to go on the paper. Okay, I think it's time to go on the take me on the desk. That's it. We need bigger scratch paper. I cannot scroll. I need to look at them at the same time, you know? So simple. These things are funny, actually. Alright. No, I like it too. I like to raise it. Paper. I hate papers, but we have to get back to them. What's going on? This is the view. This is the view. That's why actually I don't like overleaf too much too. Okay, you need to jump from one page to other page without having all the formulas next to each other. I think for me just the visual matters a lot. Who are you killing? You're already on knife. I didn't warm up. Who's there? Obama left not. Jeez. Oof, I got him. Good. this time. What a headshot. How is that possible? Oh, dude, what were you doing? Fucked up. Bitch. Double knife. But maybe actually this one. Ah. Dude, come on. Oh, I got him first. Dude, leave something for... I didn't kill anybody, but we were just. Thank you, good. That was like very 4. I'm happy I didn't get knife. Jeez. Oof, headshot. Oof. Oof! Dude, I'm killing nice. Ooh! Oh, there's this way I can't go. Who is shooting you? Distract them with the ball. Jeez, man. Who turned this on? Tony. Bro. Dude, come on. Oh, that's fine. Bro, give me a time. What the fuck? Oh, what a clean headshot. Oh jeez. Bro. Who killed you? Fucking spring right up. This motherfucker, are you here still? Dude, I got you! Jeez. Killed you. Dude, I'm killing him. This motherfucker goes there all the time, that's a stupid. H. Oh. Where is he? He died? Dude, you don't knife it, you don't die, brother. All right, stop.